Right, so we were talking about carbon compounds. So let's talk about carbon. Why is carbon so special that we need to address this, right?
Because
Yes.
it has four
So let's understand the
valence
structure.
electrons, and it's neither electropositive nor negative, and it's the first one in the whole periodic table which has four as its valence electrons. So that's why only carbon.
Right. So let us go back a little. So carbon has atomic number 6. Right. So configuration of carbon would be 2, 4. That means it has got 4 electrons in its outermost shell, right? Now what we have discussed earlier is that the configuration is designed in such a way that none of the elements would have valence electrons other than these numbers, right? So obviously 1 and 2 and 3, the elements which have 1 and 2 and 3 electrons in the outermost shell, they lose electrons in order to become stable because they have 1 or 2 or 3 excess.
But
Yes.
Like
Yes. Ask questions.
the elements which have which have atomic number more than 62, they will have valence electrons more than 8.
No.
No, but then numbers increase like 289 will
289 is not possible, no.
No,
नहीं, it
will
is
be
possible.
two.
You said कि अगर fourth shell में
Think about it. 289 is which element? That's actually potassium,
Potassium,
right? Which has got 19.
नहीं 288 के बाद like
288 what?
one. No, but then you told कि like after a
See,
specific
there are.
shell.
I have only explained till 20. There are a few more exceptions
No,
for larger elements.
yeah, that's
but
what
no, but you did.
62.
I don't remember.
Yes.
So then it is possible to have more than 8.
No, so then another exception is there.
No, but I remember you told कि they're like after like.
See,
the
I
fourth shell is filled.
what I said. Let's say, for example, if you have to write the electronic configuration of potassium. So potassium has atomic number 19. So ideally, the formula which I have given you is that first shell. So formula is 2n square, where n is the number of shell. So first shell can hold up till 2 electrons. Second shell will hold up to 8 electrons. Third shell will hold up till 18, right? And similarly fourth shell is gonna have up till 32.
Exactly. You
And
told-
mind you, this is the maximum number of electrons a particular shell can hold.
But I remember you told somewhere that after the fourth shell is.
Yes, I'm coming to that. So let's talk about. So ideally, what should have happened here is that, let's say, for example, if you're drawing potassium 19, right? So 19. Let's write the configuration for potassium. So first of all, you'll put 2 electrons in the first shell. Then you would put
2881.
8 electrons in the second shell. Then, see, first shell is completely filled with 2 electrons. Second shell is also completely filled with 8 electrons. Now, how many electrons are left with potassium?
9.
Out of 19, 2 are here, 8 are here, so 9 are left. 9 electrons should have actually been there in the third shell, right? Because third shell has the capability to hold 18 electrons, isn't it?
But exception.
But as an exception, which is there in the configuration rule, is that third shell can hold more than 8 electrons
If the fourth shell.
only if electrons are there in the fourth shell.
So yeah, so I said if the fourth shell is filled.
Yes. So then we'll put 8 electrons in the third shell, and then the next set of electron is going to go to the fourth shell.
One.
So if it's like 2888, then from afterwards, then
Yes, then we'll start filling the third shell.
Then it will be 289, then
2898.
29,
It is a possibility.
then 2810.
So then again there is an exception. That if it has to go beyond that,
Yeah, that's
then
what.
the electrons will go in the next shell.
No,
Actually, in the
After
fifth shell.
2810.
Yes.
fifth shell. So
So
then
after
it can
2,
hold
8, 10,
112.
2, 8, 10,
And if it
one.
goes on to the sixth shell, which means the third shell, then 184.
Yes. So see, it is about, see, this 2n square rule is going to go up. Let's say for example, because I didn't limit it to 4 only.
No, so
2n square is not limited up till 4, right?
Yeah.
And will it keep increasing? And the number of electrons that particular shell can hold. Let's say for example, if you have to talk about fifth shell.
50.
So fifth shell will have, yes, 50.
Sixth will have 72.
72, yes. So let's say for example, somehow at some place we find 60. Currently we have around 118 elements.
Oh,
So-
so that we can take like 5 shells.
Yes. So suppose at random place we find, let's say, 50 new elements altogether, which is obviously a
So then
possibility.
we can add them into the
Yes,
sixth shell.
yes. So we'll keep on going that way.
So like after 2810, then we'll do 2810 1. 2810.
No, 2.
2882.
Yeah.
That does not make
2883.
sense. Then why do you want to do 289? Then just simply do 2881. Right?
Yeah, so that's what we're doing now.
That's what we're doing, no?
So then why do you keep the exception that you put?
2881. That's what we did.
So it
Ah,
can't be
like, why do
doing
you
10
keep-
now.
But then you know there's an exception. That
Yeah, only if the fourth shell holds more.
Then it would be only for the elements that have like 2, 8, 8, like 1, and then 2, and then 3, and then 4.
7. Yeah.
Till 8. So 2, triple 8, like that combination.
No. Then the electron will go in the next shell. Because third shell can hold up till 18, no? So one configuration would be 2, 8, 18, 8. That is one possibility. Then the electrons will go to, if you reach this part, 2, 8, 18, 8. Then electron will go to the next shell, the fifth shell.
But how is 218 to 18?
See, for now, in 10th grade, you just have to deal with up till 20. And there is another explanation. This is not the only explanation. In 11th grade, I'll give you an explanation for subshell. And that is much better explanation. That is more convincing.
But this does not make sense. You can have 2, 8, 10.
Yes, yes.
You can have 2, 8, 10, but then you can't have 2, 8, 10, 1, but you can have 2, 8, 18.
No, who said we can have 2, 8, 10? We can't have 2,
We
8,
cannot
10.
have 2, 8, 10.
I just
have to.
asked 2, 8, 10.
No,
Yeah,
we cannot
so
have
he
2, 8,
said
10.
nah, nahi.
I said 2, 8, 8, 2.
Yeah,
2, 8, 10
okay.
is not possible. 2, 8, 8, 2. See, the entire rule is designed in such a way, and that actually exists, is that none of the elements would have a configuration which gives them the valence electrons to be any other number apart from these 8 numbers. That's how it is. So these ones, 1 and 2 and 3, they will lose electrons. And when an atom is losing electrons, let's say for example sodium. So sodium has 281. So in order to become stable by octet rule, it wishes to have 8 electrons in the outermost shell. So only possible option is, because it cannot gain 7 more electrons, so it has to lose that extra electron. And as a result of that, let's say for example if we talk about sodium, so sodium has got 281, so it is going to lose that extra electron. This electron is just going to lose, and as a result of that, it will acquire
It'll be electronegative.
electro positive. Because when electron is being lost, see, initially when sodium was neutral, it has got 2, 8 or 11, right? 11 is its atomic number. And what is our atomic number? Atomic number is number of electrons, which is also equal to number of protons. So it has got number of protons 11. That means positive charge is 11 and negative charge is 11 when it was neutral, right? Now it lost 1 electron. So if it lost 1 electron, it has got only 10 electrons but 11 protons. So as a result of that, it is going to acquire, so Na, when it loses 1 electron, it gets converted to Na plus. Right? Clear? So, and as another rule which I have explained to you, that for none of the elements it is possible to gain more than 3 or lose more than 3. So 1 and 2 and 3 will subsequently lose 1 and 2 and 3 electrons. As a result of that, they'll acquire 1 positive charge, 2 positive charge, and 3 positive charge. Similarly, 5 and 6 and 7, let's say for example, if you talk about nitrogen. So nitrogen has got atomic number 2, 7.
7.
So nitrogen has 2, 7 atomic number. So 7 as the atomic number, so configuration will be 2, 5. So in order to become stable, it is going to gain 3 more electrons, and as a result of that, nitrogen is going to get converted into what kind of ion is it going to make? Nitrogen, if it gains electrons. If an element is gaining electron.
2 minus.
Negative.
Negative, no? Because it's gaining electron.
So it will be electronegative.
That's why it will be electronegative. Right? Because nitrogen in its neutral state had 7 protons and 7 electrons. Now it gained 3 more electrons. So number of electrons became 10 and number of protons still remained 7. So 7 positive charges, 10 negative charges. Effective charge is going to be 3 minus. So that is why it is electronegative. Same with 6. Let's say for example oxygen. So oxygen has got atomic number 8. So 2, 6 is the configuration. So it will gain 2 electrons. It will get converted into O2 minus. Similarly chlorine. So chlorine has atomic number 17. So configuration is going to be, for chlorine configuration is going to be 287. So 7 electrons in the outermost shell. And as octet rule, and every element wants to have 8 electrons in the outermost shell. So it is going to gain 1 more electron here. And as a result of that, 1 excess negative charge, and it is going to get converted into Cl minus. Right? And this is the whole reason how an electrovalent bond is formed. So let's say for example, if you have Na and Cl, so Na is going to lose that extra electron and chlorine is going to gain that extra electron. So Na's configuration is going to become 2,8. Earlier it was 2,8,1, so now it is 2,8 because it has lost that extra electron, and that extra electron goes to this. So as a result of that, Na plus is formed because of loss of electron. Cl has gained 1 electron, so Cl minus ion is formed, and these two ions being oppositely charged, they'll attract each other, and as a result of that, NaCl compound is formed, which is electrovalent compound because of involvement of ions. Now the problem is with carbon, and okay, so these two are left. 1, 2, 3 we have